Welcome Year 10 to Lesson 11 of our flipped classroom tutorials. As I told you, for the next week we are looking at something called similarity. So let's have a look at what this means. So what is similarity? Well, in maths we talk about similar figures, and particularly similar triangles. The symbol that we use is like the congruency sign, but instead it's three vertical lines. And to show similarity between two shapes, we would say that, for example, that this triangle is similar to the other triangle, using that symbol in between. Similarity simply means that one shape or triangle is simply similar to another. And if the two shapes are to be similar, one, their matching angles are equal, and two, the matching sides are in the same ratio. So, I'll show you what I mean. These are two examples of similar figures. We have one triangle here and another one next to it. Now, if you know anything about computers, if I press Shift while holding the corner of this down, it changes the proportion of the shape. However, the angles remain the same. So let's make it look exactly the same as the other triangle, or congruent to the other triangle. But similar figures talk about that the angles do not change, the angles remain the same. However, the sides change, but the sides must change proportionally, or in the same ratio. So I can make it even bigger, but look, the angles will never change, just the sides, or their distances, would. This works if you make it larger or if you make it smaller. So these would be two examples of similar triangles. So, today we're not going to be looking at equal angles in similar shapes. We're going to look at equal ratio of sides. Now I've done these two similar shapes here, shape A and shape B. They are similar rectangles, to help you understand what I mean by sides that are in equal ratio to each other. So, let's match up some sides. If we take the length of shape A, which is 4, and match it up to the length of shape B. So they're the two matching sides. What we do in similarity is create a ratio or a fraction that shows the relationship between these two sides. So we'd say length of shape A over the length of shape B. Simply match them up and make a fraction. Now put in some values. The length of shape A is 4 and the length of shape B is 8. So we get a fraction which is 4 over 8. Now look at a different pair of matching sides. Now the width of this shape A is 2 and the width of shape B is 4. So make another fraction using these other two matching sides, and we would get 2 over 4. Now similarity says that if these two fractions of two pairs of different matching sides are equal, then the two shapes are similar. So the ratio of the length of each of the shapes was 4 over 8, which can be simplified to 1 over 2, and the width of each shape, or the matching sides here within the widths, was 2 over 4, and this can also be simplified to 1 over 2. If the ratios, or fractions as you may like to think of it, between two pairs of matching sides are equal, i.e. 1 over 2 is equal to 1 over 2, then these two shapes are similar. So this is what we look for. Alright, so in class, this is what we're going to do next time I see you. We're going to simply try to find missing sides in similar shapes. And we're going to use what I just showed you to help us out. So here's an example that we might look at in class. If these two triangles are similar, find the values of D, this side, and K, this side. All you need to do is follow one quick step. Firstly, just match the missing side to its partner and place it in a fraction. So if I'm trying to find D, place D and its partner, which if I look over here to the other shape is 44, into a fraction. D over 44. Then this fraction is going to be equal to a different side and its match as a fraction. So let's find a different side. Let's say this side here, 42 and 28. So if they're similar, then D over its matching side, 44, is equal to this side, 42, and its matching side as a fraction. So D over 44 would equal 42 over 28. Now to find what D is, simply multiply the base of this fraction by both sides. So D over 44 times 44, you would be left with simply D, but you need to multiply the other side by 44 as well. And we get 42 over 28 times 44. Do this on your calculator, you would find that D is equal to 66. So that might be a bit complicated, but let's have a look at another example where we're trying to find K. Match the missing side, K, with its match in the other triangle. And it'd be 27. And place them as a fraction. K over 27. Now, if their shapes are similar, then this fraction must equal another side over its matching side. So 28 over 42. And we would get K over 27 equals 28 over 42. Now again, to find K, simply multiply both sides by 27 to get rid of the denominator here. You'd simply be left with K equals 28 over 42 times 27, and it would equal 18. I'll explain this again in front of you when I have you in class, and we'll do a lot of these in our next lesson that I see you. If you really wanted to have a look at just for fun, let's test the ratios of each of these matching sides is equal. So, we quickly, as I said, we found that this was 66 and this was 18 from our last slide. Let's match each of the sides together and put them into fractions. 28 over its matching side, 42. You see a fraction here. 18 over its matching side, 27. Becomes 18 over 27. And 44 over its matching side, 66. And we get 44 over 66. Now if you simply simplified each of these fractions, you would find that 28 over 42 becomes 2 over 3. 18 over 27 becomes 2 over 3. And 44 over 66 becomes 2 over 3. And this is what I mean by matching ratios between sides. Okay. Next lesson, we're going to actually look at proving similarity in triangles, which is quite similar to congruency proofs. I'll see you next week. Enjoy the weekend.